Here we are. K of x is a piecewise function, and this one's a little different because I'm not telling you what the second function is. I'm just saying it's v of x. I'm calling it some other weird function, whatever. And I want you to find v of x, which is a linear function, it's just a line, that makes k of x continuous everywhere. Well, again, the only thing we're worried about with k of x is that the endpoints of our functions, the joints. So this cubic, this cube root of 2x minus 2, well, it's not going to be a problem until it stops at negative 3. We've got to make sure that this thing stops right where v of x picks up. So this thing's going to stop. We can find out where this cube root's going to stop. It's going to stop at x equals negative 3, and that's going to be 2 times negative 3 minus 2. Well, that's the cube root of negative 8. That's negative 2. So that's what's happening here. And really what we're calculating there, even though I don't write it out the long way, is we're calculating the left-hand limit of k of x. The left-hand limit is negative 2 at negative 3. As x approaches negative 3 from the left, k of x is approaching negative 2. Okay? So all that means is when k of x starts up at negative 3, that's v of x really, I need v of x to be at negative 2. So I need v of negative 3 to be negative 2. It has to start at negative 2. By that same logic, we need our third function, 2x squared minus 5, is going to begin at 1. Well, it has to start where v stops at 1. So let's find out what 2x squared minus 5 is at 1. Well, that's 2 times 1 squared minus 5. Well, 2 times 1 is 2 minus 5 is negative 3. Right? 2 times 1, 2 minus 5, yep, negative 3. And we need this to be what v is at 1. So let me erase what we have here. We don't need this anymore. We know that. Oh, I did need that number. Crap. Darn. This was, what was that number? Negative 3, negative 2. There we go. We need v of negative 3 to be negative 2, and we need v of 1 to be negative 3. So essentially, if you look at our graph here, at negative 3, 1, 2, 3, nope, yep, at negative 3, we need to go from negative 2, that's right here, and at 1, we need to be at negative 3. Now, it's a line, so we know that much. That's going to make this function continuous, because this cube root function is going to come right in here, and it would really have an open circle, but I'm hoping v of x fills that circle in and then gets going, because at negative 3, it equals v of x, so it's going to be a closed circle there. And this parabola, 2x squared minus 5, is going to have an open circle and go up like this. So I'm hoping, again, v of x fills in that circle when it gets there. So the only 2 points I know it has to go through are negative 3, 2. So that's what this says. When x is negative 3, the y value of v, okay, has to be negative 2. The function value is negative 2. And it has to go through 1, negative 3. Well, since it's a linear function and I know 2 points, I can find the slope of this function. The slope is y minus y, negative 2 minus negative 3, over the x value minus the x value. So negative 3 minus 1. Negative 3 minus 1. And this is going to equal, let me make some room here. Negative 2 minus negative 3 is 1. Negative 3 minus 1 is negative 4. So the slope I'm looking for is negative a fourth. Okay. So the slope I need is negative a fourth. Great. So I know that v of x has to equal negative 1/4 x plus the y-intercept. Well, to find the y-intercept, I'm just going to plug in this point, 1, negative 3, find out what b is. So v is negative 3 when x is 1. That's what that says. And I'm going to erase all this junk. I don't need him anymore. I'm going to find b, and that's going to tell me what b of x is. So this is negative 1/4 here. Negative 12/4 on this side. That's what negative 3 is. Plus b, which means b has to be negative 11/4. So b is a linear function. It's a line. And as long as it has those parameters I just found, it's going to make this function continuous. We need the slope to be negative 1/4 and the y-intercept to be 11/4. And as long as v of x equals this line, then this whole function is going to be continuous because the functions meet at the joints.